Good day, everyone. I am Jezebel A. Barcos, and today I'm going to discuss the electrochemical methods. But first, let's define what is electrochemical methods. Electrochemical methods are analytical techniques used to study chemical reactions that involve electron transfer. And it is also measure electrical properties such as voltage, current, or charge to study chemical systems. So when we say electrochemical methods, from the word electrochemical. So electro comes from electricity, it means the flow of electrons. And when we say chemical, it involves substances and chemical reaction and how they react to each other. So electrochemical methods, it means studying or using the interaction between electricity and chemicals. It involves chemical reactions and electricity. Yes. For example, in a battery, diba, in a battery, a chemical reactions creates electricity. So, ang nagpapagana pala sa mga baterya ay yung mga chemical reactions. So, when the chemical reacts to each other, it can create electricity. And electrochemical methods can create electricity. The chemical reactions create electricity, and it is also the chemical reaction can measure the electricity. Diba? That's why they have a relationship, the chemical reactions and the electricity or the electron transfer. In electrochemical methods, there are some principles. First is the redox reaction. So when we say redox reaction, it is a chemical reactions where electrons are transferred between substances. So in redox reaction, from the word redox, it is a short term for reduction and oxidation. So in redox reaction, it consists of two processes, which is the oxidation and the reductions. So oxidation is a substance loses electrons, and reduction, a substance gain electrons. So in a redox reaction, one substance loses electrons, which is oxidation, and another gains electrons, which is reductions. So when a substance loses reactions, it oxidizes, right? And when a substance gains electrons, it's reduced. So for you to remember it, just memorize the oil rig, which means oxidation is loss of electrons and reduction is gain of electrons. That is oil rig. It's easy to remember, right? So I have here an example of a redox reaction. So as you can see, zinc reacts with copper ions to form zinc ion plus copper. So in the oxidation and reduction, so in oxidation, zinc becomes zinc ion plus 2 electron. So zinc loses electrons. So as you can see there, zinc becomes zinc 2 positive. Nag-lose siya, pero nahimo noon siyang positive. Why? Because, di ba when we say electron, it is negatively charged, right? So, zinc, the atomic number of zinc is 26. So, it means it has 26 protons and it has 26 electrons. So, when zinc loses electrons, so diba it has 26 electrons. So when zinc loses 2 electrons, it becomes 24 because 26 minus 2 is 24. The electron of zinc is become 24 and the proton is 26, the same, it's 26. So mas higher ang electron. Mas higher ang proton. So, nag-lose siya electron o 2. That's why it's become zinc 2+. Because mas higher na ang iyahang proton kaysa sa electron. That's why it's become zinc 2+. And in the reduction, as you can see there, copper ion plus 2 electron to form copper. It states there that copper gains electron. So, di ba, when we say copper plus copper 2 positive, di ka ni siya nag-lose. That's why it becomes Cu2+. Since nag-gain man siya, 'di ba? Kung mag-gain siya electron, makancel ang ihang 2+. That's why mahimo siyang copper. Mahimo siyang neutral. Kaya 'di ba kung mag-gain siya electron, 2 electron. Then naa na siya daan 2 kay gikan siya nag-lose. So pareha sila na ay 2, it will cancel. Or ingno na to 2 positive plus 2 negative, may mo siyang 0, right? So that's why it becomes neutralized. That's why it becomes copper. So here, zinc and copper reaction is pareha lang gyapon siya kanina, no? Mas pinasabotable lang siya. So here, as you can see, step 2 is split the reaction into half reactions. So, gisplit lang siya ang zinc to form zinc 2 positive. It loses 2 electrons and becomes zinc 2 positive. And since it lost reaction, it is oxidized. And the copper ion gains electrons, which is reductions. It gains 2 electrons and becomes Cu neutral charge. Since it gained electrons, it is reduced. The next principle of electrochemical methods is the electrode potential. Electrode potential is a fundamental concept in electrochemical methods as it determines how electrons move between species in a redox reaction. It represents the tendency of an electrode to gain or lose electrons when in contact with an electrolyte. So, electrode potential, dito pinoportray yung redox reaction. Pinapakita dito yung paano ba nangyari yung pag-lose and pang-gain sa redox reaction. So, as you can see there, in my presentation, you can see the pictures. That is an example of electrochemical cell. Yes, in electrode potential, the redox reaction is being portrayed. Electrode potential refers to the ability of half cell. Diba? As you can see there, the redox reaction is split into half, right? The part of electrochemical cell where oxidation or reductions takes place to either gain or lose electrons. So in a redox reaction, one substance undergoes oxidation, which is lose electrons, while another undergoes reduction, right, gains electron. The electrode potential helps to quantify the tendency of each half reaction to either lose or gain electrons. The difference in electrode potential between two half cells drives the overall reactions and determine the flow of electrons in a circuit. So, makikita nyo mamaya, I will give an example. So, next is types of electrode potential. So, in oxidation potential, tendency to lose electrons, be oxidized. Higher oxidation potential, more easily oxidized. For example, the magnesium and the zinc. So, in reduction potential, tendency to gain electrons, be reduced. So, as you can see there, the table, it tells the electrode potential of the elements or the substance. Tips to interpret. Positive E, easily reduced, and the negative E, easily oxidized. So, In fluorine, it is easily reduced, right? So in magnesium, it is easily oxidized, right? So in measuring the electrode potential, you must consider the standard electrode potential. Like the 1 m concentration, the room temperature must be 25 degrees Celsius, and the pressure is 1 atmospheric pressure. And the reference point, standard hydrogen electrode, assigned a value of 0.00 voltage. So in here, I have a video. So that is an example of electrochemical cell. They have half split. The equation become half, right? Then, that is an electrode potential dahil pinoportray dyan yung redox reaction kanina, right? Kung paano ba nag-move ang electron, kung saan ba siya mag-move. So, as you can see there, what have you observed? The magnesium and copper and the zinc and copper. So, as you can see, the magnesium and the copper and the magnesium is much faster than the zinc. The movement of the magnesium to copper is much faster than the zinc to copper. Why? Bakit kaya? So let's get to know. So as you can see there are formula to compute electrode potential difference. So to determine the cell potential for a redox reaction, we have a formula of EA cell equals EA cathode and EA anode. So in a cathode, which is the reduction, the species that gains electron is more positive E and the anode is more negative E. So di ba nagpakita ko kanina na yung table na it has an electrode potential. Di ba? Doon tayo kukuha. Right? So, an example calculation for zinc to copper. So, as you can see, the copper ion become copper neutral. Diba? Reduction. Diba? When we say reduction, gain ng electron. Right? So, the copper ion become copper because since copper ion is di kan siya nag-lose of electron, that's why it becomes 2+. So since Cu magiging siya ng electrons, so they have both 2. So magka-cancel yon, right? So the E is given plus 0.34, di ba? As you can see here, the cathode is more positive E, that's why it plus 0.34 volts. And as you can see, the zinc becomes zinc ions, so anode more negative, that's why it's 0.76 volt, and it's oxidation. When we say oxidation, it's loss of electrons. That's why the zinc becomes zinc 2+, because mas higher na yung protons niya kaysa sa electrons. Then substitute lang, then the answer is 1.10 volts. And the magnesium to copper naman, same process lang. Then substitute, then becomes 2.71. So since magnesium to copper has a larger voltage, 2.71 versus 1.10 volts for zinc to copper, electrons transfer is faster. Kaya pala mas faster yung transfer ng magnesium to copper is because it has a higher voltage than zinc to copper. That's it. It's so simple. So next principle of electrochemical methods is the Ohm's law. In electrochemistry, Ohm's law is applied in the context of electric current and resistance in electrochemical cells. The law states that the current passing through a conductor is directly proportional to the potential difference and inversely proportional to the resistance. It can be expressed as I equals V over R, where I is the current measured in amperes and V is the potential difference voltage across the conductor measured in volts, and the R is the resistance of the conductor measured in ohms. So I have here an example. So you can see there a problem. First problem is a galvanic cell consists of a zinc electrode and a copper electrode. The measured voltage of the cell is 1.1 volts and the total resistance of the circuit including the electrolyte and wires is 5 ohms. What is the current flowing through the circuit? So we use the Ohm's law, where V equals 1.1 cell voltage and the R is 5 total resistance. So the missing there is the I, right? So we're going to find the I. We're going to find the current, right? So just put the given the 1.1 V in the voltage and the 5 in the total resistance, and then just divide it. The answer is 0.22 amperes. So the current flowing through the circuit is 0.22 amperes or 220 to 20. Right? So the next problem is finding the resistance. So here's the problem. During electrolysis of water, a power supply provides a voltage of 6 volts. If the current flowing through the water is measured to be 1.5 amperes, what is the total resistance of the electrochemical system? So the R is missing. So R equals V over I. Just divide it and you can get the answer. So simple lang siya. And during electrolysis of water, a power supply provides a voltage of 6 volts. If the current flowing through the water is measured to be 1.5 amperes, what is the total resistance of the electrochemical cells? So we're finding again the R. So just put the given, then the answer is for resistance. That's it. So the next principle of electrochemical methods is the first Faraday's law of electrolysis. So Faraday's law of electrolysis describes the quantitative relationship between the amount of substance deposited or dissolved at an electrode and the electric charge passed through the electrolyte. These laws were formulated by Michael Faraday in 1834 and are stated as follows. So there are two laws of electrolysis. So the first law of electrolysis, it is the mass of a substance deposited or liberated at an electrode is directly proportional to the quantity of electric charge passed through the electrolyte. So the first law formula is M equals ZIT, which is M is equals to mass of the substance deposited in grams. And the Z is the electrochemical equivalent of the substance in grams. So the I is the current in amperes and the T is time in seconds. So meaning the electrochemical equivalent tells us how much of a substance in grams is deposited per 1 coulomb of charge. So different elements have different values of Z because the molar mass and the valency are different. So Z equals, to get the electrochemical equivalent, this is the formula. Z equals to M over number for N and Faraday's law. So the M is the molar mass of a substance, which in grams per mole, and the N is number of electrons involved in the reactions or the valency, and the F is the Faraday's constant, which is 96,500 charge of 1 mole of electrons. So I have here an example problem. In an electrolytic cell, a current of 4A amperes is passed through a solution of silver nitrate for 1 hour. How much silver is deposited at the cathode? So given is the atomic mass of silver equals a, di ba, 108 kung kukunin mo yung per mole. Atomic mass of silver is 108 grams per mole, and the valency of silver is 1, and the current is 4 amperes, and the time is 1 hour is equivalent to 3,600 seconds. So we will use Faraday's first law of electrolysis, which is given by. But before we can use this formula, we first need to get the electrochemical equivalent. So let's get the electrochemical equivalent. So since the mass of Ag is 108, we put it in the top, and the valency is 1 times the Faraday's law constant, and the answer is 0.001112 grams, right? So the step 2 is use the formula to calculate the mass deposited. So now that we have the electrochemical equivalent, we can use the formula M equals ZIT to find the mass of silver deposited. So substitute the unknown value into the equation. So nag-given naman yung Z, right? The equivalent. So M equals 0.00112 times 4, which is the valency, which is the which is the current, and the T is the time. Then times equals to 16.128 grams. So the final answer is 16.13 of silver is the deposited at the cathode. So next is the second law of electrolysis. So when the same amount of charge is passed through different electrolytes, the masses of substances deposited or liberated are proportional to their equivalent weights. So M1 over M2 equals E1 over E2. These laws help determine how much material will be deposited in electrochemical process such as electroplating or electrolysis in industry. So the second law formula is M1 over M2 equals E2 over E1 over E2. So M1 and M2 is equals to masses of different substances deposited, and E1 and E2 is equals to equivalent weights of the substance. So equivalent weight is given by E equals M over N. Meaning if the same amount of charge is passed through different electrolytes, the mass of substance deposited is proportional to its equivalent weights. So this means heavier elements deposit more mass if they have the same valency, and higher valency the elements deposit less mass for the same charge. So I have here a example problem. In an experiment, 2.5 grams of copper is deposited at the cathode. When a current is passed through a copper sulfate solution, how much silver would be deposited under the same condition, assuming the current and time are the same? So given is the atomic mass of copper, which is 63.5, and the atomic mass of silver is 108. Valency of copper is 2, and the valency of silver is 1. When we say valency, copper can lose 2 electrons, and silver can lose 1 electrons. So in solution, we will use Faraday's second law, electrolysis, which states that the masses of substances deposited during electrolysis are directly proportional to their equivalent weight. So the step 1 is calculate the equivalent weight of copper. So in finding the equivalent weight, we have the formula E equals M over N. So the M is the molar mass of the substance and the N is the valency of the substance. So for copper, the molar mass of copper is 63.5 grams per mole and the valency is 2 because it can lose electron of 2 electron. So the equivalent weight of copper is 63.5 divided by 2 is equals to 31.75 grams per equivalent. So here, since nakuha na natin yung molar mass ng copper, next is we have to get the equivalent weight of the silver. So for the silver, the molar mass is 108 grams per mole and the valency is 1. So 1 lang yung kakayahan niya na mag-loss ng electron. So the equivalent weight of silver is 108 divided by 1 is equals to 108 grams per equivalent. So the step 3 is use the Faraday's second law to find the mass of silver deposited. So gaya nga nung sinabi ko kanina, the formula of Faraday's second law states M1 over M2 equals E1 over E2. So the M1 and the M2 is the mass of the first substance and the second substance, which is the first substance is the copper and the second substance is the silver. So the E1 is equivalent to weight of the first substance copper and the E2 is the equivalent weight of the second substance. So we are given that 2.5 of copper is deposited and we need to find the mass of silver deposited under the same conditions. Substitute the value into the equation. So in M1 is 2.5 and the E1 is 31.75, which is the equivalent weight of the copper, and the E2 is 108, which is the equivalent weight of the second substance, which is the silver. So solve for the M, which is for the Ag, is equals to, so just cross multiply the 2.5 and the 108, then copy the 31.75 since it has 31.75 times 1 is 31.75 and 2.5 times 108 is equals to 270 over 31.75 is equals to 8.5 grams of silver will be deposited under the same conditions. Thank you for listening.